Okay, so ocean foam is pretty easy. It's not literally whitewater that we're going to get from our flip simulation, and as you saw in Fluids 2, hopefully. Ocean foam is really just going to generate some points where there's like the biggest crests in the waves, and then it's going to move them around with the velocities generated from the, from the actual waves moving in the first place. So nothing terribly intensive sim-wise. This is technically a sim, so I'm going to say sim ocean foam. And I'm going to keep calling it ocean foam to distinguish it from the whitewater foam. So jump in here. We're going to need our spectrums with masks and all that jazz that we developed. So object merge in this. Obviously, you could also read them from the disk, but there that is. In any other case, it's called ocean foam. And let's start it off in emission mode. This is a SOP that contains the sim stuff inside of it. So we're not going to be dealing with a DOP network or anything in this time. Ocean foam, like I said, simply looks at, and you can see our mask and stuff kind of. It looks at the spectrums and then just says, well, where was it higher? Where was the cusping? The tops of the waves. Where was it higher than 0.25? Put some points there. And then later switch to solver mode and move them around, also based on the spectrum. And that's it. So all we need to do is find a value of this that we like. I don't want much foam on this. This is not a raging ocean. So I'm going to say maybe we'll start at 0.6. And then what else we want to do? We got to say, where do these points spawn? Well, we need them to spawn to infinity, technically, even though we won't really see them out there. You can go to camera and just choose the only camera we have. And I'm going to take this back down again for a minute. And now you can see it's doing a camera frustum approach to this. And what's nice is that because of the Z density fall off, it's putting more in the front. If you had this not on or lower, it will equally distribute them. But you really don't need it. We're barely going to see it in the front as it is, to be honest with you. So go back to this, but then maybe concentrate some points around them. And let's see. As the camera moves to the left, we want this region over here to have kind of started to simulate already. So let's have it the window, the X of the window, meaning here's our window, and this is the left X side, the negative X. Have it extend where it starts to spawn particles before we even get to it. So that's about it. So that's where the points will be spawned anyway. And then the solver mode, if you turn it into solver, we'll just take those and now it will accumulate them instead. So we'll have more points than we just saw there. It's a pretty fast sim, as you can see. It really just needs the time it takes to read those spectrum and then just slightly move those points around is pretty much all it needs. If we looked at it closely, what it's done so far, you can see it's a flat plane. Just like the way our oceans are being rendered as a plane that's displaced, this foam is going to be plugged into the shaders as well and also be displaced. So it also starts from being a flat plane. If we were to scrub, you can see it move with the waves, which is cool. But that's about all we really need to do. So let's grab one of these these file cache things here, plug it in, file cache ocean foam. Again, it's mad because these files don't exist and it's trying to read them. Now this is, like pretty much everything else we do in this lesson, is going to be frame range based. So change it back to frame range. Revert this back to default so that it's f start to fn, start to end. And don't forget, we need to, after the $OF and before the BGO.SC, put a $F, because now we need these to actually, cache frames and not just one frame. So going to our out area, this ocean foam is dependent on the spectrum and masks being done. Technically, anyway. We're not actually reading the files that they wrote, but conceptually they are. It is dependent on that. So let's have that come after this merge, or rather, I should just say, let's make a new merge here and say, this is the ocean foam. It points to this. And then it continues on its way. This will kind of be like our dedicated merge that separates us from the render stuff. If you hold A and left click and swipe up, it'll organize everything above it, which is what I'm doing here. You know, if you want to, or you can move them around yourself, like that. Cool, save it. I'm gonna start disabling things up here that I've already run. That way when I click on this and I say render this, it's not gonna also rerun the stuff that came before. So I'm gonna let this go for a minute and then we'll plug it into our shader, render it, and move on to the actual flip stuff. Actually, I just thought of something though. We talked about pre-roll, or at least we will talk about pre-roll. Actually, we haven't talked about it yet. But this sim can't just start on frame 1. This foam needs to exist in our view on the first frame. So it needs to have started simming beforehand. So go back to our ocean foam solver area here and say start frame should start at frame -36. And you can see here, that's what it's doing. We're on frame 1 right now, and it's trying to show us frame 1. And it can't show us frame 1 until it has run the previous 36 frames. Now it has, and now on frame 1, we have foam already. Our cacher will still only cache frame 1 to 120, but we'll still have to run through the first 36 frames to get to frame 1. So now with that done, let's cache that.